Okay, let's talk about algebra. But wait, I promise this isn't the algebra you remember from school. We're not talking about dusty chalkboards or trying to find x for the 100th time. No, we're talking about algebra as a secret weapon for making some of the most difficult high-stakes decisions you can possibly imagine.
I mean, seriously, think about it for a second. When was it? If you're like most people, the answer is probably high school, right? And you remember it as this abstract, pointless exercise. But what if I told you that couldn't be further from the truth?
Because the real power of algebra isn't about solving for some forgotten variable in a textbook. It's about finding answers when the stakes are literally life and death, or the success and failure of a massive project. We're taking this out of the classroom and putting it right into the crucible.
So let's kick things off with our first case, linear algebra. Now, in school, it's all about drawing straight lines on a graph. But in the real world, it's the cold, hard logic of trade-offs. It's the math you turn to when you don't have enough to go around and you have to find the absolute best possible outcome. I want you to just imagine this for a second. You're in charge. The hospital is completely overwhelmed. Every single choice you make has a very real human cost. And your job is to somehow use math to make the most ethical decision possible, even when every option feels wrong. Okay, so here's the reality on the ground. These are the hard facts, the fixed limits of your world. You have exactly 50 ventilators and 200 ICU beds. That's it. And you have one single unwavering objective: save the maximum number of people. Everything else, it's just noise. Now this is where it gets really, really tough. This is how human lives get translated into a resource allocation problem. Just look at patient type C. To treat one of them, you need 2 ventilators and 2 ICU beds, but their chance of survival is only 10%. This is the absolutely brutal calculus you're staring at. And there it is. That's the gut punch. When you run the numbers using a method called linear programming, the purely logical, optimal solution to maximize lives saved is to give the most critically ill patients nothing. The math shows that the resources they would consume could save so many more type A and B patients. It's like an ethical guillotine, and it's sharpened by algebra. All right, let's pivot to a totally different kind of high-stakes environment, the world of business. Life is rarely a straight line, right? Things have diminishing returns. This is the world of curves, of parabolas, and of course, quadratic equations. So here's a question every entrepreneur faces. You've got a new product. What do you charge for it? If you price it too low, you're just leaving money on the table. But if you price it too high, nobody buys it. There's a sweet spot, right? A peak on a curve that algebra can help you find. So your company's profit can actually be modeled by an equation, something like this one here. Now, don't get hung up on the numbers. This equation is basically the DNA of your business model. And the most important part is that very first term, the negative 5p squared. Because it's negative, it tells us the graph of our profit isn't a straight line. It's a parabola that opens downward, like an arch. And what does every arch have? A single highest point. That's your maximum possible profit, and algebra tells you exactly where it is. And boom, there it is. By finding the vertex of that parabola, the math tells you that the one single optimal price is $125. Not a dollar more, not a dollar less. That right there is the absolute peak of your profit curve. But here's the real power move. What if you do all this math, you find that absolute maximum profit, and it's still a negative number? Well, the algebra has just handed you a priceless piece of information. It's screaming at you to kill this project right now, before you waste a single dollar. It's a truth detector for your entire business plan. Okay, for our final case, we're going to dive into something our brains are just notoriously bad at: probability and uncertainty. This is where a type of thinking called Bayesian algebra becomes a superpower, because it corrects our flawed intuition right when it matters most. So picture this. You get this news from your doctor. You've tested positive for a very rare disease, one that only affects about 1 in every 1,000 people. But the test they used, it's incredibly good. It's 99% accurate. A positive result? It feels like a death sentence. Your mind just starts racing. So what do you think? With a test that's 99% accurate, the chance you're actually sick has got to be, well, it's got to be pretty high, wouldn't you say? This is what almost everyone's intuition screams at them. The test is 99% accurate. I tested positive, so there's a 99% chance I have the disease. It seems so simple, so logical, and it is completely dead wrong. The actual probability that you are sick is only about 9%. And I know that sounds crazy, so let's break it down. Imagine we test 1,000 people. Since the disease rate is 1 in 1,000, we expect only one person in that group to actually be sick. The 99% accurate test will almost certainly catch them, so that's one true positive. But now, what about the 999 healthy people? Well, the test has a 1% false positive rate, so it's going to incorrectly flag about 10 of those healthy people as being sick. So now you have a pool of 11 positive tests, but only one of them is the real thing. Your chance isn't 99%, it's 1 out of 11.
And this isn't just some clever party trick. This is the exact kind of calculation that can stop a doctor from ordering a dangerous, invasive, and totally unnecessary procedure, all because of a misleading test results. It's a firewall of logic protecting you from fear and your own flawed intuition. So, from a chaotic hospital ER to a tense boardroom to a quiet doctor's office, we've seen how algebra brings clarity. It's so much more than a school subject. It's really a mindset. You can think of it as an operating system for making rational choices in a messy, complex world.
And it all kind of boils down to these 3 simple steps. First, just define your reality. What are the things you can actually control, and what are the things that are fixed? Second, figure out the rules of the game. What are your limits, your constraints? And third, use logic to solve for the truth, even and especially if it's not the answer you wanted to hear.
So, I'll leave you with this one question to think about. We all tend to assume things are linear, that if we put in twice the effort, we'll get twice the results. But the real world is almost never that simple. So, what's one area in your own life where you might be applying that kind of straight-lined thinking to what is actually a curved reality? Finding that answer, well, it might just change everything.